In this section, we'll talk about skew lines, and we call skew lines the lines that are not parallel and do not intersect. In order to check whether a couple of lines are skew, we'll have to do that through the exclusion method. So we'll have to first check whether the lines are parallel. And if they're not parallel, then we'll have to check whether the lines intersect. And if they do not intersect, then we'll conclude that the lines are skew. Now, in the following example, we're asked to determine whether the lines L1 with parametric equations x equals to 1 plus 2t, y equals to 3t, and z equals to 2 minus t, and L2 with parametric equations x equals to negative 1 plus s, y equals to 4 plus s, and z equals to 1 plus 3s are parallel, skew, or intersecting. So in order to determine whether the lines are parallel, we'll have to check whether the two vectors that are parallel to the lines L1 and L2 are a scalar multiple of each other. So for the line L1, the vector V1 has components 2, 3, and negative 1. So 2, 3, negative 1. Essentially, these 2, 3, and negative 1 are the components A, B, and C of the line L1. And for the line L2, the vector V2, which is parallel to the line L2, has components 1, 1, and then 3. So 1, 1, and 3. So since these two vectors are not scalar multiples of each other, so since V1 is not a scalar multiple of V2, then the lines are not parallel. So let's now check whether the lines intersect. In order for the two lines to intersect, there should be a point with coordinates x, y, z, where the two lines intersect. And in this case, the x, y, and z will be equal between the two lines. So we have from the first line that x is equal to 1 plus 2t, and this is equal to negative 1 plus s. This is the x of the line L2. And we have that y is equal to 3t, and this is equal to 4 plus s from the line L2. So we'll have to solve this system of two equations and then plug the values t and s to the z coordinates in order to find whether we find something that makes sense or not. So from the first equation, we have that 2t is equal to negative 2 plus s, and from the other equation, we have 3t equals to 4 plus s. So let's call this equation 1 and this equation 2. So subtracting the equation 1 from the equation 2, so 2 minus 1, will give us that t is equal to 6. So t is equal to 6, so we have 3t minus 2t is equal to t, and then 4 minus the negative 2 is equal to 6. And substituting that t equals to 6 to either the equation 1 or equation 2, let's try the equation 2. So we have 3 times 6 is 18, and then minus 4. So that gives us that s is equal to 14. So now we'll need to substitute the t and s to the two equations for z. So we have that z is equal to 2 minus t, and this is equal to 1 plus 3s. So substituting t and s, we'll have 2 minus 6 is equal to 1 plus 3 times 14. So that gives us that negative 4 is equal to 43, which is not possible. So not possible. And therefore there is no solution, so the lines do not intersect. So the lines do not intersect, they're not also not parallel. So in this case, the conclusion is that the lines are skewed.